So this is problem number 10 from Wiki Extra Credit Problems. So the problem is a voltaic cell has an aluminum electrode and aluminum sulfate solution in one compartment, and the other compartment has lead electrode and lead sulfate solution. And what we're looking for is which solution has a greater tendency to oxidize, aluminum or lead, and draw a diagram of a voltaic cell, and which electrode will increase in mass. So what I like to do first is I like to write down my givens. So the givens are the aluminum electrode, which is Al solid, and then an aqueous solution of Al2SO43. And we also have lead solid, which is the lead electrode, an aqueous solution of lead sulfate. Okay, so what we are looking for in part A is which solution has a greater tendency to be oxidized. So to be oxidized means it loses electrons. And in order for us to find those, in order to find the oxidized, which one's the oxidized one, we need to look at cell potentials, which is E naught. And because we know it's a voltaic cell, we know it's a galvanic. And that's by definition. As well as in a galvanic cell, the anode is negative, meaning the E naught, the cell potential, is negative, which means it's oxidized. And the cathode is positive, or more positive than the anode, and it's reduced. Okay, so to begin, first we need to find the oxidation states and then the half reactions, so we can use the reduction potential table and find their E naught values. Okay, so first let's find the oxidation state of aluminum. So we have, since we're doing since we're going to do half reactions afterwards, we need to find the oxidation states of the aqueous solution because we know the solid is 0. So Al2SO43 now has an overall charge of 0. And we know that sulfate has a -2 charge. So it has a -2 charge times 3 of those, -6. And we have 2 aluminums. Oops, sorry, that was supposed to be 0. So the aluminum has a +3 charge. So now we write our half reaction. So we have, the half reactions have to be in reduction. So we have aluminum 3 plus goes to aluminum solid. So this is 0, this is +3, we need 3 electrons. So we will go on the table and find the E naught. Aluminum is right here. -1.676. -1.676. So it's negative. So that could mean it is the anode. But first we need to compare it with the lead. So now let's do the oxidation state of So we have Pb SO4. The overall charge is 0. So this is -2, and there's only 1, so it's -2 is equal to 0 plus Pb. So Pb has a +2 charge. Now for the half reaction. It's Pb 2 plus, again in reduction, going to Pb solid. This is 0, that's a +2, so we need 2 electrons on both sides. So now we look for the E cell of this, which is equal to I don't know if you guys can see very well, but it's -0.125. -0.125 volts. So which one is more negative? Is the anode, which is equal to the oxidized one. So as we can see, aluminum is more likely to be oxidized. Okay, for part B, we need to draw a voltaic cell, including the following. So since we know a voltaic is a galvanic cell, we know that the oxidized element is the anode. So we can just choose. So we need to draw 2 compartments. Okay, let's just say this is the anode, which has a negative charge, and this is the cathode with the positive charge. So the anode, as we concluded, is the more negative, which means it's aluminum. So we're going to draw the aluminum metal for the solid. And then let's draw the lead. Be solid, and they're both in aqueous solutions. Aluminum has an aqueous solution of Al2SO43, and lead has PbSO4, and they're aqueous. And now we need to draw the electron flow. And the electrons always flow from a negative to a positive, always. So here's the electron flow. Usually you can like put a light bulb right here if you want to draw one showing use of the electron transfer. And we also need a salt bridge in order to allow the ions to move between cell compartments to complete the circuit. And since we know that SO4 is a spectator ion with a negative charge, it's a negative ion. And since we don't have any other ions, we don't have a positive. So we cannot draw a positive ion. But let's draw the salt bridge. So here's the salt bridge. It needs to be underneath the aqueous solution. And since the salt bridge allows ions to move between the compartments, we know that the ion is SO4. And since it has a negative charge, it's going towards the negatives. the spectator on. It's negative, goes to the negatives. If we had a positive, it'd go to the positive. So that's it for that. So for part C, it says which electrode will increase in mass. So by definition, the electrode that will increase by mass is the one being reduced. And the one being reduced is lead, Pb. And you can also see that all the electrons are moving to the lead, so they're accumulating, causing more mass. So I hope you guys enjoyed this.